In this experiment, we will need the thermal efficiency apparatus, the water pump, 2 DC power supplies, 3 multimeters, a 5-watt load bank, a beaker, and ice. Let's use the 3 rubber hose lines to circulate hot and cold water through our system. Run the first tube from the thermal efficiency apparatus, where it is marked cooling water out, to the beaker. This tube will be dispensing water back into the bath. Run the second tube from the TE, where it is marked cooling water in, to the pump outlet. Run the third tube from the ice water bath into the pump inlet. These last 2 tubes will be used to pump water into the thermal efficiency apparatus from the beaker. Power the water pump using the 2 banana plugs and the power supply. Turn on the power supply, and after the initiation, adjust the voltage to 3.2 volts. Use 2 banana plugs to connect the second DC power supply to the TE, where it is labeled heater. Set the voltage of the DC power supply to 10 volts. Note that if the digital display on the DC power supply is highlighted CC, you will not be able to adjust the voltage knobs on the bottom of the interface and change the voltage. As shown in the video, we are adjusting the current knobs to change the voltage to 10 volts. Connect one of the 3 multimeters into the 2 white thermistor terminals at the top of the TE. Set the multimeter to measure ohms. The reading on the display of the multimeter should correspond to either the hot side or the cold side of the water flow. To change from one to the other, flip the switch beneath the 2 white thermistor terminals. Note that the hotter temperature should correspond to the lower reading. The resistor fixed into your load bank is assumed to be 0.5 ohms. To confirm the actual value of this resistance, connect a multimeter into your load bank. Put the banana plugs on the middle and right jack of the load bank. Set the multimeter to read ohms. After taking this reading, leave the multimeter inside the load bank and set it up to read voltage for V fixed. Now look at the diagram in your lab manual. To read the voltage VW, or the load resistance, set up a multimeter running from the left and right sides of your load bank. Now that we have our voltage reading set up, connect the 5-watt load bank to the TE. Run patch cords from the bottom left and bottom right jacks on the TE to the right and left sockets of the load bank. It helps to keep consistent with the grounds. Use this setup as a reference. Now the circuit is complete and should look a little something like this. We can start to test the TE for power delivered. Through each test, we will be changing the load resistance to find the optimal setting. Note that each test we will have to keep some things constant, such as RH, or the resistance of the thermistor on the hot side. To do so, we will have to adjust the power supply voltage. Measuring the load resistance RW before and after our series of resistance, current, and voltage readings. The easiest way to do this is to remove the bottom right plug on the TE. By doing so, the multimeter reading VW, or the one plugged into the left and right sockets of the load bank, can be set to ohms to read the load resistance RW. When the load resistance is set to its desired value, for example 3 ohms, then we can start our test readings. Make sure that the hot side resistance of the thermistor is maintained at its previous value by adjusting the power supply voltage if necessary. Then we can take our series of readings from the multimeters and the displays. After we take all our readings that are required, we can disconnect the previously mentioned banana plug and read our load resistance at its second value, RW prime. We want to take readings at load resistances across the entire range of the potentiometer to find out the optimal setting. We can also take 2 readings at one load resistance setting to measure the accuracy of our system. After all of our trials are complete, we can turn off the power supplies.